Okay, ladies and gentlemen, welcome to my channel, and today we'll be discussing about a new topic called city sizing and how to select a city basically for your electrical engineering work and how to specify its specifications. Okay, so let's see, there are very simple steps and you will understand step by step how to select a city basically, and once you select a city, how to write its specification in the single line diagram. Okay, let's see. Now see, basically this is your SLD, okay, and let's say you can say like this is your power transformer, okay, and this is your secondary side of your transformer, okay, and you have to provide a CT here for a metering purpose, and this is one more CT is here for your protection purpose. This is for your metering, this is for your protections, okay. So there are two types of CTs are there. One is for your metering, okay, metering CT, and second is your protection CT. Okay, there are two types of CTs. Now let's say this is your transformer, and the transformers you can say this is 11 by 0.415 kV transformer, okay. Let's say this is a 1000 kVA transformer, okay. Since the 1000 kVA transformer, so I think as per my knowledge, your full load current will come around secondary current. The secondary current will come around equal to something 16666 amps, something around, or you can say 1600 amperes, okay. Let's say if you multiply 1.6 secondary current, you can calculate, you know how to calculate the secondary current of the secondary side of a transformer, okay. You will get secondary current 1600 amperes, okay. Now how to select a CD? Just you can multiply the 1600 by a factor 1.25, okay. You can consider 10%, 15%, 20%, 25%. Maximum that much margin is there. 20 to 25% margin you can consider on a CD on the secondary side of a transformer, okay. If it is a feeder feeding your motor, okay, then you have to calculate what is your motor full load current, okay. So basically you should ensure what is the current flowing in a normal condition through your conductor. So whatever current is flowing, whether it is a transformer feeder, whether it is a motor feeder, you have to calculate the full load current. On that you have to multiply with 25%, that is 1.25, you have to multiply it. This value, I think you will get around what is this value? This value is around 160, 10%, 20, is 320, 20 and more 180, okay, 400. Okay, somewhere around 400, this value will give you around 2000 amperes, okay. So you will select a standard rating, a CT of 2000 by 1 ampere, okay. This is a CT ratio, you can call it as. So basically whatever value you get, based on that value you have to select a standard rating of CT, okay. Now what is the standard rating? Standard rating could be your 2200. So normally standard rating you have a 2000 amp CT, so I have selected 2000, okay. Suppose you have got your current, let's say you have got a current of 2100 or 2150, let's say, for example. After multiplying with 1.25 something, you have got this value, okay. You have maybe your primary current maybe something 1800, okay. I am just randomly taking some figures. Into 1.25 I got this value. So 2150 is not a standard rating, so you can go to the nearest standard rating available, that is 2500, okay. The nearest standard available rating is 2500, that you can consider this. So this is how, suppose you have got a value of 2800, so nearest standard rating may be 3000, you can go for 3000 ampere CT, okay, 3000 ampere CT. So this is how you have to select the CT ratio, okay. Now you will understand how to write the CT specifications, okay. Let's see, this is your feeder, okay. This is your feeder and this is your breaker, okay, and this is your motor. Now let's say we have considered one more different example for motor feeder, okay. So we have considered CT here. See, CT is normally, it's a core, okay. It's a core which is imbibed in a primary conductor. So it is installed, let's say you are having these three conductors are flowing, across this CT is placed, the core is placed, okay. Is that clear? So basically this is a single conductor. Across the CT core is there, okay, and there is on this core there is a secondary winding which is connected, okay. This is shown in the single line diagram as a single line. So the secondary winding is connected like this, and across this there is a, you can say there is a meter is connected. This is a meter, or you can say ammeter, or even a relay in a protection CT. So this is how is the figure in the 3-line diagram, or you can say in a detailed way. So how to specify a CT rating? How to specify a CT rating? Okay, we'll see much detail here. I will specify first. I will specify its current ratio. Let's say current ratio is 2000 by 1 amperes. Okay. Then we have to mention the burden on CT. That is 10 VA. Okay. Burden means what is the relay connected with? This is the resistance of the secondary wires, secondary coil, or you can say pilot wire. This pilot wire, or connecting leads also you can say. Okay. And the load, the resistance of this meter. Here you have connected ammeter, or it could be a something relay. So relay coil or ammeter coil, that load. So connecting this load of secondary resistance, okay, resistance RS plus this load, that is RL. Okay. So this is your total RS plus RL, that into this current, secondary current, whatever is flowing, you will get the VA. So VA is equal to secondary current into resistance, secondary coil resistance plus the connected load resistance. Okay, total resistance. This will give you burden in the VA form. So it is hardly 10 VA or 15 VA for a metering CT. Okay. So normally these values you may get from the vendor. You have to ask to the vendor to give you this detailed calculations. Okay. In a consultancy, basically you are not supposed to do the calculations for a CT burden. You can ask from the vendor and he will give you. Okay, for your reference. Okay, fine. Since this is a very simple calculations. Because whatever relay or whatever meter is connected, it has some coil and it has its own load. So that details will be definitely with the vendor. So he will be the best person to do the sizing for this CT. Clear? Okay. And one more point here is, there's one more specifications where you have to mention is the class of the CT class. So normally for a metering CT, it is class 0.1 or 0.2, or you can say 0.5. Okay. For industrial CT, the class is 1, 3 or 5. So what is this value? 0.1 means it is 0.1% error. 0.2, 0.5 means 0.5% error. 1 means it's 1% error. Okay. So normally in industrial metering, if you see in a cement plant or any petrochemical plant or any oil and gas refinery, wherever in the plant section, if you see there is a class 1 CT they use, class 1, because 1 means 1% error. And if you see any energy company who is very who want to measure the energy basically, because there the precision, there the accuracy is very important. Any energy metering company like MSCB is there. Okay, he has to measure the feeder, how much is the energy consumption. Then they go, so basically we will go for a class 0.5 because they want accuracy 0.5 or 0.2, 0.31. If in a lab, in laboratories, they use normally 0.1 or 0.2 because their accuracy is much more important. Okay, for an energy company, it is 0.5 meters, 0.5 class. Clear? So three things only we have to specify. That is your CT ratio. This is called the CT ratio. That is the current ratio. Primary current to secondary current. This is a burden of a CT. Okay, burden. And this is your class. Protection. This is called the CT class. We can call it as. Okay. So this is how we have to mention the CT specification in the SLD. Okay. Now we will see how to specify a CT specification for a metering, for a protection CT. This is what we have discussed for metering CT. We will see now for a protection CT. So concept is same, selection concept is the same. Same way you have to calculate the full load current into 1.25. You will get some value. That from that value you have to select the standard rating. So let's say because the ratio is normally for a metering and for a protection CT, the ratio is same thing. Okay, we have considered here metering. This is a metering ammeter. Okay, we have considered a metering CT here. We will show here the protection CT now. So the ratio is same, 2000 by 1 ampere. Now the burden is 15 VA, or we can say it could be a 20 VA also. Same way again, calculations we have to ask to the vendor. He will provide you. Okay, if you demand it. and this is the protection feature, the class of the city, 5P10. Now let's see there are values something like 5P10, okay, 5P5, you can say 5P5, 5P10, 5P15, okay, 10P5, 10P10, 10P20, okay, 10P30. These are the values. So now what is this? Understand properly. This is one of the interview questions they ask in an interview with regards to this of a city. Okay. Now let's see. This first digit is the error. This is the error in the city, 5%. Okay. If you see this 10P10, this 10 is the 10% error. Okay. So, but obvious, we will select a city who will be giving you only less error, that is 5%, because here it is giving more error, that is 10%. Okay. Error means what? There is an error in the conversion of your current ratio. For example, if your CT is, let's say, 3000 amperes, so to convert this 3000 to 1 amps, there will be an error of, let's say, 5%. So if instead of 1 amperes, you will get in the output that is 0.95 amperes, because there is a 5% error. It is plus or minus 5% error. It could give you 1.05 ampere or so. Okay, this is a small minor error. Okay, this is this 5P is for protection, and this is for your ALF. This is called as a ALF factor. Okay, ALF here is 5, 10, 15. Okay, now we will understand what is ALF. Okay, it's a very important factor. Try to understand. So ALF is basically your accuracy limit. It is a ratio basically. It's accuracy limit primary current to the rated primary current. Okay, it's a ratio. It's the accuracy limit primary current to the rated primary current. Now what is this exactly? What do you mean by that? When you say my ALF is 10, okay, my ALF is 10, my rated primary current is how much? It is 2000 amperes. Okay, this is my rated primary current. So 2000 into 10, if you do, you will get values around 20,000. Okay, so this is a 20,000 ampere current. That means when in the primary, when 20,000 current is flowing, that means it is 10 times of your primary current. In that case, the error will be 5%. Okay, try to understand. 5P10, 5P20 or 5P15 जो भी है, that value is what? Accuracy limit primary current to the rated primary current. It is a ratio. Okay, this means when your primary current is around 20,000, or if it is more than 10 times or more than 15 times, if your ALF is 15, okay, so it is 15 times of your primary current. So till your current is 15 times of your primary current, the error will be still to 5%. It is meaning that. Okay, that means if you see the specifications 5P5, 5P10, 5P15, even 5P20, if you see this, okay, if you see this, more the ALF, better the CD, because error is same 5% everywhere. So if you were to select a CD between 5P5 and 5P20, which will be better? Of course, this 5P20 will be better, because error both are giving same 5% and it is giving limited until when? Till 20 times of your full load current. Okay, so if you have to select a city between 5P5 and 5P20 or 5P10 and 5P20, 5P20 will be a better one as compared to 10P5 or 10P30. Who is better? Compared to this two, definitely 5P is better. Okay, and if you have to compare between 10P5 and 10P20, 30, this is also 10%, this is also 10%, and this is giving you ALF 5, here ALF 30. So definitely 30 is better. Okay, in industries normally 5P10 or 5P20 is most probably used, because this is giving you less error and error. So this 5P20 is much more used city class. Try to understand. I'm just giving an example. Nobody uses 10%. This is very, because the error is more 10%. Okay, doesn't make any sense. So I hope you understand how to write the city specifications and how to select a city basically. Okay, if you like my video, please give a thumb. And one more point I would like to tell you is that our online sessions, classes are going on the weekends, batches, or even also on the weekdays. So if you are really interested and if you are very much serious to enter into this career, please call on my number displayed on my thumbnail. Okay, and if you like my channel, please give a thumb and subscribe my channel and keep watching, and so that you will keep on gaining and learning